All right, welcome back. Why did the moon skip dinner? Obviously, because it was already full. Ha, ha. Okay, so we have once we've learned about exponentials, now we're going to apply it into real life. Now, with exponentials, there's two things that we care about. It's either growth or decay. And so obviously, growth would make sense that we use that kind of shape. And for decay, it makes a lot of sense that we would use that kind of shape. Okay, so as things grow in time, normally when we talk about time, time goes from left to right. And so growth would be getting larger as I go from left to right. And decay would be it's kind of decline, decay. Anything would be getting smaller as I go from left to right. Okay, so that there are your two different kind of shapes. Now, where is this used? Heating and cooling is kind of modeled by a lot of exponential kind of stuff. Population is often exponential. And also, if we talk about finance and compound interest, it's compound interest is supposed to be exponential growth. And if you're talking about loan repayments, it's also technically, especially if it's declining balance, it will be a, what do you call it? Exponential decay. Okay. Um, so here's an example of a question. It's going to use an exponential. And again, very similar to your quadratic models and any type of models, we now no longer see X and Y. We are now given different variables. Okay, so in this particular question, it says the weight of a baby in the first 4 months of age can be modeled by W equals to 3 bracket 1.1 T, where W is the weight in kilograms and T is the time in months. Complete the table of values and hence sketch. Okay, now I've already made a little mistake here. Oh no, this is fine. I actually haven't. That was a joke. So T represents time, W represents weight, and then we've got all these other things, and you can clearly see because T is a power that this is going to be some sort of exponential graph. Okay, now what we want to do is if I'm talking about the weight of a baby and if I'm talking about time, what would be my logical first number? My logical first number would have to be 0. Okay, there's no point in doing negatives. And because we're talking about the first 4 months, I'm going to go 0, 1, 2, 3, 4. Those are the first 4 months. Okay, now how would I find the weight? This is where you substitute it into your formula. So again, this is where I would put brackets in your working out. Or in this case, you actually don't have to. So, or not any extra ones anyway. So 3 times 1.1 in brackets to the power of, and you plug in your values. When t equals 0, which is otherwise saying when the baby is just born, it is 3 kilos. There's a big baby. Okay, now after the first month, that means I go to the power of 1. That baby is now going to be 3.3 kilos. At the second month, it's going to be 3.6 kilos, or technically 3.63. At the 3 month mark, the kid is 3.99 kilos, and at the fourth, 4 point. I'm just going to round it to one decimal place. Yeah, I want to round it to one decimal place. So this one will be 4.0. Okay, just to make my life a little bit easier. And so for this one here, I'm going to complete the table of values and hence sketch. So I'm going to say that's 0, 1, 2, 3, 4. That's nice. And I have to now pick an appropriate scale where the growth is in between 3 and 4. And I can't just write 3 here. It has to be to scale for this to kind of work. And so for what I'm going to do is that's going to be 1, 2, 3. Yeah, okay. I'm going to make that 1, 2, 3, 4. And this will be kilograms. So this is the weight in kilograms, and this is the time in months. Okay. So at time equals 0, the baby is 3 kilos. So I'm going to put that in there. And then it becomes 3.3 kilos at 1 month. It becomes 3.6 at 2 months. It becomes essentially 4.0 at 3 months. And then it becomes 4.4. And you can see it's not perfect, but you can see that there is a very slight upward curve. And if we were to keep going, I assume it would give a little bit of a curve, but it's not there. So this is only for the first 4 months. So we've done the first 4 months, we've plotted the points, we've sketched it. Now, what is the baby's initial birth weight? Initial is a fancy way to say when there's no time that's been going on. That's a fancy way to say time equals to 0. So how big was this baby when he was born? What was the weight? This particular one is 3 kilos. Okay. Now, this question is an interesting one. What is the monthly growth rate? Now, you can see here that the growth rate has got to do with this value in here. Now, remember when we were talking about that last lesson, if this number was less than 1, it would decrease. If it was greater than 1, it would increase. And so it's definitely greater than 1, but it's only greater than 1 by a little bit. So because it's greater than 1, 1.1 means that there's an increase of 10%. So that means each time we're increasing by 0.1, and that's the same thing as saying 10%. So each month, it grows by another 10%. Now, what are the limitations of this model? Very similar to some of your quadratic models. Time must be positive. And also, something to note about a model like this, it's only used for the first 4 months. Okay, now, what happens if we keep going and forever and ever and ever? Because you and I are probably like, what is it? How old? If you guys are like 16 and that means technically you've lived maybe like roughly 192 months. It's not going to keep working. The reason being is, do we keep growing in weight, or do we somehow at some point probably stop growing in weight? Okay, most people will normally, I don't know, it's different for everyone, but at some point, I've been the same weight since I've been in high school. I haven't increased. And so it's helpful to note that it's just like we stop growing. Whereas this model is going to predict that we're going to keep on growing. Okay. So things like if we're talking about height, at some point you reach a maximum height and then you don't grow anymore. Same thing with weight in general. You don't grow like you'll hit a certain weight and the general population will not continue to increase. So these are things that you need to think about when you're talking about these types of models. I hope that helps, and I'll catch you guys in the next one. See ya. Bye.